Welcome to this new video with Math Mentor. By the end of this lesson, you should be able to solve simultaneous linear equations graphically. Last time, we learned how to solve linear simultaneous equations using the elimination method. If you haven't watched the video, the link will be in the video's description. Before we start solving simultaneous linear equations graphically, we need to understand what a graph is all about. A graph is a diagram showing the relationship between two variables, each measured along one of the pair of axes at right angles. Examples of graphs may include a displacement time graph, a velocity time graph, a bar chart, and so on. Consider a number line with its center normally at 0. Duplicate it and rotate the line 90 degrees counterclockwise such that their centers intersect as such. We now have two axes, the vertical axis called the y-axis or the ordinates, and the horizontal axis called the x-axis or the abscissa. This pair of axes hold points that we plot as an ordered pair xy, where x must be a value along the x-axis and y a value along the y-axis. Imagine a line drawn from the y-unit parallel to the x-axis and from the x-unit parallel to the y-axis. These two lines intersect at a point xy, which is the plot of that point. Recall that any straight line can be written in the standard form y is equal to mx plus c, where y and x are general points on the line, m is a gradient of the line, and c is the intercept of the line with the y-axis. It is important to get used to these words. General point. This is simply any point anywhere along the line satisfying the equation of the line. Intercept. These are points either on the x and y axis where a graph cuts the axis. We basically have two intercepts. The x-intercept where the graph cuts the x-axis. At this point, y is equal to 0 since there is no height from the center in the y direction. And the y-intercept where the graph cuts through the y-axis. At this point, x is equal to 0 since the graph has no width from the center in the x direction. To draw a straight line, we need at least 2 points, which can be linked up with a ruler and a line drawn. If we have more than 2 points, they will just align on the line satisfying the equation. These points can easily be obtained at intercept for graphs that cut the x and y axis. For graphs with no intercept, they cut neither the x or y axis and so pass through the origin. That is, from y is equal to mx plus c, the graph has no intercept with the y-axis, and so c is equal to 0, leading to y is equal to mx. So graphs of the form y is equal to mx pass through the origin. Examples of such graphs include y is equal to x, y is equal to 3x, y is equal to half x, and so on. Simultaneous linear equations can be solved graphically by drawing straight lines of their linear equations on the same axis. The point of intersection gives the solution set of the linear simultaneous equation. Let's demonstrate with this example. Y is equal to negative x plus 5, and half x minus y is equal to negative 2. Letting y is equal to negative x plus 5 to be line L1, and half x minus y is equal to negative 2 to be line L2, and we begin by finding any 2 points on these lines. Considering line L1, since it is of the form y is equal to mx plus c, we can find its intercept with the y and x axis. Finding the x-intercept, the value of y is equal to 0, and so we substitute y is equal to 0 and obtain 0 is equal to negative x plus 5. Solving for the value of x leads to x is equal to 5. So the point 5, 0 is the x-intercept. Now, solving for the y-intercept, we substitute x is equal to 0, and so we have y is equal to 0 plus 5, which is equal to 5. So the point 0, 5 is the y-intercept. Therefore, the point 5, 0 and 0, 5 are 2 points on line L1. Moving on to line L2 and finding the x-intercept, we substitute y is equal to 0 into line L2, giving half x is equal to negative 2. Solving for x by multiplying both sides by 2 gives x is equal to negative 4. Hence, negative 4, 0 is the x-intercept. For the y-intercept, we substitute x is equal to 0 into line L2 and we obtain 0 minus y is equal to negative 2, leading to y is equal to 2. So 0, 2 is the x-intercept. Hence, negative 4, 0 and 0, 2 are 2 points on line L2. We can now proceed and draw the graphs using the grids below. For line L1, we plot the point 5, 0 and 0, 5, which are the x and y intercepts respectively. Now we link up this point with a straight line, and we are going to obtain this line. For line L2, we need to plot these 2 points, negative 4, 0 and 0, 2, which are the x and y intercepts respectively. So, plotting the points and drawing a straight line linking them, we obtain. Notice that the lines intersect at a point 2, 3. So, it is an ordered pair giving x is equal to 2 and y is equal to 3 are the solutions of the pair of simultaneous linear equations. Remark: for a graph of the form y is equal to mx, it passes through the origin and therefore has no intercept. We may choose any 2 points satisfying the equations. For example, for the line y is equal to half x, we can draw the table below and then obtain values of y when x is equal to 1, 2, and so on. And we are going to obtain the following values. The graphical method is not quite accurate. Substitution and elimination methods are preferable. For example, if the graph intersects within a grid, we can just estimate the values of x and y, which may not be accurate. In the next lesson, we will be drawing and interpreting quadratic graphs. Stay tuned. Don't forget to leave a like, subscribe, and ring the bell icon for more videos. Thanks for watching.